Welcome to this presentation that's going to walk you through how to use what we dub the metric stairs as a convenient way to move from one unit to another within the international system, or SI, or the more common nickname, the metric system. Continuing on our work here, using the metric stairs after our discussion of the benefits, immediate disadvantage of everything turning to the metric system within the US. We're going to show you some of the benefits of the ease of going from one unit to another and knowing by the name of something within the metric system as to whether it is large or small in the measurement sizes that we're reporting things in. So using the metric stairs, what you're going to do is draw a base step, and then from that base step you'll draw 3 steps below and 3 steps above. The metric system is of course based on the meter, which reminder is from the Greek word metron, meaning to measure. And the metric system is very much centered on this meter as the base step, that each step going downwards is similar in going down in an elevator in a hotel, large building, or simply going downstairs, you're going from a higher to a lower number of floors within a building. And of course the opposite being true, as you go up the stairs in a building or up an elevator, you increase in a height from the floor, from the base level, or your numbers increase from floor number to higher. To help you become more one with the meter, and hence the metric system, it's important to realize how much length we're talking about when we say 1 meter. 1 meter is about the length of a guitar. It's about the width of a door frame. A baseball bat is about 1 meter in length. So these are a couple of things that can help you visualize as we start to think about parts of a meter and more than 1 meter. If we were to go down the stairs, as I mentioned, you're going to decrease in floor number or height in a building. If you were to chop the meter stick into 10 even pieces, one of those pieces is known as the decimeter. One of the keys of the metric system is the prefix list here. And these prefixes are what are the key to letting us know if something is large or small in the metric system. Deci means 1/10. Something I'd encourage you to do to help you become more familiar and more one with the metric system is to think more in terms of what numbers and place values are representing, this being 1/10. Rather than saying 0.1, 1/10 will help you easily manipulate your thoughts up and down the stairs of the metric system. Now, most certainly, you can continue to say 0.1 without any form of penalty. This is just a tip I'm offering for you to help you adjust to thinking more metrically. 1/10. If we then take this decimeter and chop it into 10 even pieces, one of those even pieces would be called the centimeter. You're very familiar with the prefix of cent, as the US cent makes up 1/100th of a US dollar. 1/100th. So a centimeter is about 1/100th of a meter. I shouldn't say about, is 1/100th of a meter. What I mean to say is it's about the width of an average finger. Now in class, when we ask you to show us a centimeter, choose wisely and give us a nice pinky finger, index finger. If you then, of course, fit the pattern that we're beginning to establish, if you take the centimeter, chop it into 10 even pieces, one of those pieces would be known as the millimeter, as milli means 1/1000th, 1/1000th. A millimeter, if you take your thumb and forefinger, hold it up to a light and bring that thumb and forefinger together, right before it looks like the skin of your forefinger and thumb are touching, that amount of light coming in is approximately representing the width of your space of 1 millimeter. And as you are looking at the distance between the thumb and forefinger as they come together and right before the skin touches, you probably have a nice little crunchy face going. So 1 millimeter. The meter sticks and rulers, smaller rulers that you'll be using in this class, are going to have these markings. This 90 is representing 90 centimeters. And then the 1 through 9 in between are representing 91 centimeters, 92, 93, 94. So this gap, this distance here is 1 centimeter, and the other units we'll be using very commonly as well will be these next sort of targets, or what we call accepted values on a ruler, and that is the distance representing 1 millimeter. So between 1 and 2, the distance of a centimeter, we have 10 of these millimeters. Again, these are the markings you will be seeing on the meter sticks and smaller rulers, usually 30 centimeter rulers you'll be using in the class. These divisions represent 1 centimeter, and these tiny slivers are 1 millimeter. We went down by tens, 1/10, 100th, 1,000th. Pattern is still going to hold as we're going to increase by 10. So if I have 10 meters, I'm going to refer to that as 1 decameter. 1 decameter. The deca representing 10. If I then have 10 decameters, that would be 100 meters. We call a hectometer, because hecto means 100. 1 hectometer is 100 meters. And up to this step that you've drawn, if I take this 100 hectometers and have 10 of those, I end up with 1 kilometer or kilometer. Kilometer or kilometer. A kilometer then represents 1,000 meters. Reminder, you're going to be most commonly measuring and recording your observations in centimeters and millimeters. And the steps, these metric stairs that you've drawn, there's more steps above and there's more steps below. Later in physics, we'll get into some smaller SI prefixes. And the larger terms, you're probably more familiar with, less from your science classes and more your computer science classes or interaction with computer technology. I want to direct your attention here to this prefix. This prefix, you'll see, is to be pronounced giga. So Doc Brown on Back to the Future, professing 1.21 gigawatts, is actually pronouncing this correctly. And that's one of the benefits I mentioned of the metric system. Unlike something in the standard system like a furlong, the unit of a furlong doesn't instantly tell you whether that's large or small in scale. So a furlong, is it the length of a bear fur? The length of a rabbit fur? How long is that fur? Using these prefixes for our base steps, that allows us to instantly think about you're dealing with something large or small. If we're to say I had 1 kilo cookie, that means I have 1,000 cookies. If I have 1 centi cookie, cookie being the base step comparable to a meter, if I have a centi cookie, I have 1/100th of a cookie. We're looking at crumbs that I have. Back to this giga, the world of computer technology has more so adopted the phrasing of giga, gigabytes, and this is actually how someone ended up with their nickname. An engineer was on a radio show and he corrected the radio host saying that it's not actually giga, but it's giga, and the radio host turned to the engineer and said, "What, are you some sort of science guy?" And that's how Bill Nye got his nickname. And this is me another lifetime ago, the beginning of my teaching career, a couple decades ago, with Bill Nye, the science guy. One of the advantages of the metric system are these prefixes, that the prefix can tell you how big or how small a base unit is. And remember, anything can be considered a base unit. If I have a henry, a millihenry, 1/1000th of a henry. A microhenry, 1/1,000,000th of a henry. If I were to have 100 henries over here, that would be a hectohenry. In this area of the page entitled International System, you want to have drawn these stairs. This is the base unit, 3 steps below, base unit 3 steps above. And what is at the heart of the metric system, of course, is the decimal. If we zoom in very closely, we see deci, the dino decimal. The metric stairs allow us to convert from one unit to another within the metric system. 54 hectometers is how many centimeters? Now, several of you can do this in your head, and that is excellent. That's a great skill. I'm going to walk you through the metric stairs to show you how you would use them in case something wasn't as familiar or as easily calculable in your mind. So the metric stairs, here's our base step. The very first step of the 3 rules of the metric stair use would be 1, copy the number. We copy this number right here, 54. Anywhere you copy it is fine. Your second step is find deci. Deci is right here to the right of the 4. And deci is on the step of hectometer. And deci wants to go to centimeter. So that's all involved in finding deci. In the number that you've copied, right after the 4, deci's on the step of hecto and wants to go to the step of centimeter. The third step is to move deci. So deci's here and wants to go here. So we're going to move 1, 2, 3, 4. 4 steps. Now the 4 steps allow us to know how many decimal places to move deci. The direction we move this up or down the stairs tells us which direction to move deci. One of the things I like about the use of these metric stairs is you don't have to really kind of calculate in your mind, do I multiply, divide, am I getting a bigger number, a smaller number, I'm starting with 10,000. This is very simple, hopefully. You copy the number, find deci right after the 4, move deci from the hecto to the centi, and then you will move deci 4 places to the right. Now we know to move to the right because it appears to the right when you go down the stairs rather than to the left when you go up the stairs. So the way to know which way to move the decimal, if deci goes to the right, you go down the stairs. If deci goes to the left, you go up the stairs. In the metric system, it's always important to think about moving the decimal. Moving the decimal to the right because you went down the stairs, moving the decimal to the left because you went up the stairs. It's really not about adding or taking away zeros, because if you think about it, 54 adding 4 zeros is still 54. Taking away 4 hours is still 54. So it's all about moving deci, moving the decimal. So 54 hectometers, as many of you knew before, using the metric stairs, is 540,000 centimeters. Do another example. 1 decimeter is how many or how much of a meter. Many of you can do it in your head, but just to show you another example with the use of the stairs. We first copy the number, so the 1 we copy, and we find deci. Deci's to the right of the 1, and deci is on the decimeter step, and deci wants to go to the meter. Third step would be to move deci. You move deci from the decimeter to the meter step, so it's 1 step. That 1 step up the stairs is to let you know to move the decimal 1 place to the left. 1 decimeter is then 1/10 of a meter. Oh, yes, it is 1/10 of a meter. I just want to highlight something for those of you going on to college or university, as many of you say, because you're taking physics for scholarship reasons. So looking at the decimal here, deci the dino. Deci the dino doesn't like to be all by the lonesome, so likes to be surrounded with a number on either side of the deci. So it's important to include a leading 0. This leading zero can help you greatly as a consumer. If you take a look at this image here that I see all too often. This Aqua Vista water is on sale for 58 hundredths of a cent. 58 hundredths of a cent. Now the cent is part of the dollar sign symbols. You know it takes 100 cents to make a dollar. If I have 58 pennies, I have 58 hundredths of a dollar. Or I have 58 cents. 58 cents. This decimal 5/8, or say 6/10 of a cent, is showing you this water is less than a penny. If we use these leading decimals, or excuse me, leading zeros more, we're less likely to see this misrepresentation in signing. Now, by law, you are able to pay the posted price. That protects you as the consumer, but also to protect the manufacturer from errors. They are able to sell just one. You can't go in and buy their whole stockpile of their Aqua Vista and buy each one for less than a penny. So protect you as the consumer, you pay the posted price, but also to protect the manufacturer, the sales company, you can only purchase one at this definite mistake. A little bit of give and take in the world, may as well tell them, hey, here's my penny, keep the change. In this class, we will only use the metric system, so no more filthy I words, F words, so on and so forth. All other forms of British Standard or the Imperial system, they're banned. Keep it all metric, as only SI is spoken here, just like in this wonderful road sign. Metric Boulevard meets Centimeter Circle. So here we are in meeting our metric world.